Hi everyone, this video is an exercise 11J question 3. So we want to find a general solution to this differential equation. Okay, the first step is because we want to use separation of variables, and while this may not look very clear at the first glance, we can basically use a typical technique. So first of all, we need to try to keep the, let's say, y terms on one side and then the x terms on the other side. So one thing that we can do is basically taking a factor of y on the right hand side, because that gives us 1 plus x. And now we are at a position to use separation of variables, because we can divide both sides by y. So y will go to the other side. And also we can divide by x squared, so that we'll have 1 plus x over x squared on the right hand side. And now we can multiply by dx. So we get 1 over y dy is equal to, first of all, let's split this fraction, which becomes 1 over x squared plus 1 over x. And remember that dx goes there, so like this. And now we can just integrate both sides. So the integral of 1 over y is just ln mod y. And now here, when we integrate 1 over x, we also get ln mod x. But when we integrate 1 over x squared, then that's just equal to minus 1 over x. It's just something from pure 1. And obviously c is the constant of integration in this case. Now we can do e to the power of both sides. So we'll have e to the power of ny is equal to e to the power of x minus 1 over x plus c. Okay, and at this point, remember that there are some cancellations, and because e and ln cancel out, so we'll have mod y is equal to mod x, modulus x, or the absolute value of x, minus 1 over x plus, so e to the power of c, it's equal to a, let's say, because that's just an arbitrary constant. But here we can also rewrite that as maybe, wait, I made a mistake here, because first of all, so what happens here is that we'll have this x on the denominator, and then here is minus e to the power of minus 1 over x, and then times e to the power of c, which is just a. So for simplicity, in this case, we can just say that we can just drop the modulus, because we can consider a as a constant that absorbs the sign changes. So we don't need to make this very complicated by including the modulus. Again, because this is for A-level course, so it's not very rigorous, and we don't need to worry about the modulus too much for questions like this in A-level maths. Anyway, so now that we have this nice form, this is the general solution, and in part B, we want to find a particular solution to the differential equation which satisfies this boundary condition. So we just substitute x is equal to minus 1, y is equal to e to the power of 4, and then we'll find a constant of integration, basically, and that gives us the answer. So we have e to the power of 4, and then remember that x is minus 1. So we have minus a times e to the power of minus 1 over 1, which is just 1. And this means that a is simply equal to minus e cubed. Therefore, the particular solution in this case is minus e cubed x e to the power of minus 1.